So in this problem, we're told to verify that the function satisfies the three hypotheses of Rolle's theorem on the given interval. Then find all numbers C that satisfy the conclusion of Rolle's theorem. Then we're supposed to enter our answers as a comma-separated list. So we're given this function here, f of x equals 3 minus 16x plus 2x squared, and we're given this interval, closed interval, from 3 to 5. So let's first talk about the criteria of Rolle's theorem. So the three hypotheses are, in order for us to use Rolle's theorem to make sure that it works, our function and our interval, so it must be continuous from the closed interval from a to b. So this function right here must be continuous from 3 to 5. It also must be differentiable from the open interval of a to b. And then finally, f of a has to be equal to f of b. So with these three criteria in mind, let's see if they actually work out for what they gave us. So is the function continuous from this closed interval of a to b? Well, we know that polynomials are always continuous from any interval, so that means this is going to check out. So first criteria is satisfied. What about differentiable though? Same thing, since it's continuous, it's always going to be differentiable. So this function right here, this polynomial, or all polynomials are differentiable. So then that means this is also going to be differentiable. But what about, is f of a going to be equal to f of b? So let's just test that out. So if we just say that 3 is going to be a and b is going to be 5, let's just test them. So f of 3 is equal to 3 minus 16 times 3 plus 2 times 3 squared. So if you plug this in your calculator, just solve it, you're going to get that it equals minus 27. Now let's try 5. So f of 5 has to be equal. So if we plug in 5, we're going to get 3 minus 16 times 5 plus 2 times 5 squared. And so if you solve this too, you're also going to get that it equals minus 27. So if f of 3 is equal to f of 5, and in this case minus 27 is equal to minus 27. So then that means the third criteria checks out. So what does Rolle's theorem tells us? Well, it tells us that f prime of c is going to be equal to 0. So basically c, what we can do is just take the derivative of our function, set it equal to 0, and then that value of x is going to be our answer. So let's go ahead and do that. So f of x equals 3 minus 16x plus 2x squared. So let's find the derivative of it. So f prime of x is equal to the derivative of 3, which is 0. Then derivative of minus 16x is just minus 16. And the derivative of 2x squared is plus 4x. So we just move the 2 down and subtract 1 from our exponent. And then so minus 16 plus 4x is going to be equal to 0. So if we solve for x by moving 16 to the other side, 4x is going to be equal to 16. Then we divide both sides by 4. We're going to get that x equals 4. And so x in this case is basically c. We just wrote x. Then that means c is going to be equal to 4. And so our answer to this question is going to be 4.